Okay, ready? Yes? Is it a yes? Yes? Okay. Good. It's a trinomial, correct? Is it in descending order? Negative leading coefficient? Greatest common factor? 6x. So please tell me what you have in parentheses.
X squared
Yes?
plus 9x
X squared plus 9x plus.
plus 20.
Good. So now I'm focusing on x squared plus 9x plus 20. Is this a special product? It's not a special product because 20 is not a perfect square, correct. So then we're trying to find what? Because 1 is the leading coefficient. What we're trying to find? Yes? Two numbers whose product is? And whose sum is? Good. Do we have them? So how do I write it? That's it. Do you think we need more examples from this category? Okay. Very good. I only asked. Okay, 57. X to the third minus 2x squared minus 24x. One minute. Let me draw your attention for 1 second. You can finish up as soon as possible, I hope, 6.2 and 6.5. These are done. Of course, this is done as well. 6.2 and 6.5, done. Okay. Do we need more time? Okay, so it's a trinomial. Is it in descending order?
Yeah.
Greatest common factor? Perfect. What is left in parentheses? Now, do you appreciate this greatest common factor, taking it out? Because otherwise it's a killer, right? So remember, you always make your life easier if you factor out the greatest common factor and the negative leading coefficient. I caution you, the book does not show this. But in chapter 7, they say, oh, I'm sorry, we forgot to tell you this in chapter 6. So we have to do it. Okay, now I'm looking at x squared minus 2x minus 24, and I'm asking myself if a special product is applicable here. No. So then I'm down to the category in which the leading coefficient is 1. Good. So I'm looking for two numbers whose product is 24, product negative 24, and whose sum is negative 2. Since the product is negative, what numbers am I looking for? Negative and positive. Very good. So you can write this. So the product is negative 24, and their sum is negative 2. Please tell me what to write. X is outside, yes. Okay. Do you all agree with x, x minus 6, x plus 4, yes? Okay. So one more time, do we need more examples of this? Of course, after I finish the trinomials and we look at polynomials, we're going to review everything we've studied by simply selecting all sorts of problems and not in a particular order. Now I'm selecting in a particular order, right? Because we're talking about trinomials. But after I finish this, one more step for trinomials, number 7, and we finish polynomials, then we'll go back and redo everything. No. No. Absolutely not. No. Not this week and not next week. No. Allow me to. No. We have to look at it. I think we schedule it roughly around the 30th. No. I still need time for this. Okay. Any questions? Any questions here?
Other than this entire lesson is going way over my head and I'm completely confused.
Oh, but I would like you to tell me what is not clear.
Everything.
From trinomials?
I guess the one thing is, hold on, I gotta look at the steps again, but I should be able to find it. The 5-step, the 7-step things we were doing.
It's right here. We have not talked about the step number 7. We are still in step number 6. Step number 7 is a little bit more difficult.
I have to say probably the special products is what's getting me.
Yeah, the two special products, they come from chapter 5, actually. If you remember when we said, okay, if I have a minus b squared, I should never FOIL it again.
Okay.
And I should say the first term squared minus 2 times the first times the second plus the second term squared.
Okay.
So these two come from chapter 5. There are only two special products for trinomials. For binomials, we have 4.
Alright.
However, one of them is not factorable.
Okay, so I have a lot to practice.
Yes, but we will practice more. Okay? I don't expect anyone to go out the door tonight knowing how to factor everything. Okay? So my intention is to finish everything tonight. The trinomials with item 7 and polynomials with 4 terms or more. And on Thursday, I'm going to start all over again.
Okay.
Because it needs time. Everyone needs time. It's not you. Okay? So let's choose another 2 or 3 problems here. Let's look at 58. We have x to the third minus 3x squared minus 28x. Remember the strategy? We have to go through all those questions. What is it? Is it in descending order? Greatest common factor. What do you have in parentheses when you say x? What is left? Yes. Yes? Good. The next step in the strategy is special product. Is the special product applicable here? Because of negative 28 is not a perfect square also. Correct. So then the leading coefficient is 1. So I'm looking for two numbers whose product is
Oh,
negative 28, and whose sum is negative 3. Can we find those numbers? But 7 and positive 4 will not give us a negative 3. Negative 7 and positive 4 will give us a negative 3, correct? Oh, I'm sorry, forgive me, I didn't hear. It's not intentional, really. Negative 7 times 4 is negative 28. So then I know the factored form. Correct? Very good. So this is indeed the factor form. Do you think we can move on to the last strategy for trinomials, which is the most difficult one? Yes, of course. Let's say number 40. So 2x squared minus 24x and plus 70. So let's work on this problem for 1 minute. Yes, 70. Yes. Sorry, my handwriting. Do we need more time? It's a trinomial. Is it in descending order? Negative leading coefficient? Greatest common factor? Good. Please tell me what you have.
Minus 12 plus 35.
Good. Special product? No, because 35 is not a perfect square. 1 is the leading coefficient? Yes. So then I'm looking for two numbers whose product must be and whose sum must be negative 12. And you said negative 7 and negative 5. Negative 7 plus negative 5 is negative 12. The product is 35. Excellent. So then 2, and then you will tell me how to factor this. Any questions? Do we feel a little bit better about this with one leading coefficient? A little bit? Okay, can I move on then to the last item on the list of trinomials?
Wait,
Yes.
let's put the x plus 5.
Negative 7 minus 5 is negative 12. Negative 7 times negative 5 is positive 35. Actually, it's a very good question. Let's do this. You probably forgot to put parentheses or something. So x times x is x squared. Negative 5x minus 7x is negative 12x. And negative 7 times negative 5 is 35. Better? Okay, perfect. So now here is, I'm coming back to my handout because I have some problems here, and I would like to start with those. And then we'll select from the book. 10. My page 10. 6 y squared minus y minus 1. Okay, what is it? Is it in descending order? Greatest common factor. Is 6 a factor in all three? No. So greatest common factor? No. Negative leading coefficient? Special product? No. It's -1, and 6y squared is not a perfect square anyway. Good. 1 is a leading coefficient? No. So I'm down to the very last possibility. Okay. Here's what we need to do now. The sum of the numbers I need does not change. Is what?
-1.
Yes. The sum is -1. The coefficient, -1. But the product now changes. In the past, it was just -1, right? In the previous example, right? With the 1. But this time is this product. This is the product. It's -6. When the leading coefficient is not 1, I must incorporate it in the product, not in the sum. Sum never changes.
3 multiply those two numbers.
6 times -1, I get -6. So now, can anyone give us two numbers whose product is -6 and whose sum is -1? Since the product is negative, we're expecting a positive and a negative.
-3 times.
Do you all agree that -3 times 2 and -3 plus 2 fulfill the both requirements and there is no other pair of numbers? Would you agree? So their sum is -1, their product is -6. Would you agree? Please pay attention. You don't have to write anything for 1 minute. Just 1 minute. Watch, and then I'll give you time to copy. So once I discover these two numbers, I am going to use them to rewrite the polynomial. 6y squared does not change, but -y changes into -3y plus 2y. Instead of -y, I use the numbers we determined, and change -y into -3y plus 2y. This sum is still that. And of course, I'm going to copy -1. And now you'll say, and I will have to agree if you say that, and you'll say, okay, so what did you accomplish? You changed 3 terms into 4. Right? True. But here's what I do next. I'm looking at the first 2 terms. Assuming that they're alone, what will you factor out? What else? 3y. What is left in parentheses?
Y squared. I'm sorry, y. 3y.
What should I get from the other 2 so that I can continue factoring? What should I get from the other 2 so I can continue factoring?
3y.
I have to have the same thing. If I don't have the same thing, I will not be able to continue. 2y minus 1. And now I look. I need here a sign, and I need here a factor. What times 2y is 2y? What times -1 is -1? Sign. Good. And the factor? 1. If you said 1, I think you said 1. It is 1. So now I have 2 terms. This is one term, and this is the other term. And they have a common factor, and I need to pull it out. What common factor you see in these 2 terms? Identical quantity that will come out. No, I don't see 2. I see 2y minus 1. This is what I see. So this is coming out. What is left from the first term?
3y plus 1.
What is left from the other term? Plus 1. We need a lot of problems here. It's going to be very easy in few minutes. In few minutes. Not the first one, maybe not the second one. Okay? I'm checking my work. It only takes 5 seconds to check my work. 2y times 3y is 6y squared. Positive 2y minus 3y is negative y. Negative 1 times 1 is negative 1. So this is the factored form of 6y squared minus y minus 1. So please copy it if you want, and then we'll look at other examples. Even the second one will be hard. Even the third one possibly will be hard, but then you'll get the hang of it. No difficulty after that. But it doesn't get harder than this. And this is it. That's for the, no, for factoring. For factoring. So this procedure here, from this step till this step, it's called, and I would like you to write it down, this is very important, factoring by, what do you think? By grouping. We grouped the first two together and the last two together. So this is factoring by grouping. Super important. Say it again. Yes. Any questions?
So the product, if it's not 0,
If it's not 1.
it's not 1, sorry.
Yes. Then you have to incorporate this coefficient in the product. Then you find the numbers. Then you replace the middle term using the numbers you determined. And then you will come up with four terms. And then you will factor by grouping, and you have to come out with the same thing. Otherwise, you cannot continue.
Can you leave it just like that?
So it's not, the method looks different. Yes, please.
So let's say like you get when you're doing factoring by grouping, and you can't break it down into where it's the same. Is it not?
Very good question. If I found the numbers whose product is whatever and whose sum is whatever, it's definitely factorable. If I cannot find those two, excellent question. If I cannot find those two numbers, I know it's not factorable, and I'm not going to even attempt anything because I will not be able to break the middle term into anything. Because I will not be able to find two numbers whose product is and whose sum is. I will not even get to that stage. Excellent question. Without a 1 at the end? Yes, of course. That's my next problem. Any questions on this? Okay. And again, it does not, in factoring, it does not get harder than this. So 4x squared minus 4x minus 15. I have to go through all steps. Please do not omit anything. Please. Number 1, what is it? Is it in descending order?
Yes.
Greatest common factor. Negative leading coefficient. Special product. 1 as the leading coefficient. We're down to the very last option, which means we are looking for two numbers whose product is, don't forget the signs of those numbers, whose product is negative 60 and whose sum is negative 4. So let's think. We want to find two numbers whose product is negative 60 and whose sum is negative 4. Can anyone come up with two numbers whose product is negative 60 and whose sum is negative 4? Excellent. Negative 10 and 6. Do you all agree with negative 10 and 6? Both conditions have to be fulfilled. Is negative 10 plus 6 negative 4? Is negative 10 times 6 negative 60? Okay, so then the next step you will tell me what to write. Can anyone dictate the next step? And mind you, this is only the second example. And you already know what to tell me.
You have to rewrite it.
Good, I'm ready.
4x.
4x squared
Minus 10. Minus 16.
We did not change the problem because negative 10x plus 6x is still negative 4x. Do you agree? Okay, I'm ready now. And I'm not kidding when I cover those two. This is what I do. I write the factor before I even look, because exactly what Shane said, okay, what if I write something crazy? It's possible. This is not what you said, but what I was getting at is, what if I don't see that the common factor in the last two is whatever, and I get stuck? So I'm looking at the first two. What will you pull out? What is left in parentheses? What should come out from the other two for sure? Which is? Now I look. I need sign and factor. If you forget the sign or if you forget the factor, you can mess it up.
3.
Sign plus 3. What is the common factor from these two terms that comes out in front?
Of the 2x minus 5.
Very good. What is left from the first term?
2x plus.
Not that bad, right? The first one looked very difficult, right? Any questions? Tim, go ahead.
I'm just lost.
Which part?
Step where you, I guess, pull or replicate that. Like,
So is this clear and I pull out from these two 2x?
Yep.
Is it clear that I pull out 3 from here?
Yep.
Okay, so now I am taking this right here in front.
Okay.
What is left from the first term?
2x.
What is left from the second term?
Okay.
Okay, next one. 2x squared plus x plus 1. What is it? Is it in descending order? Greatest common factor? Negative leading coefficient? Special product? 1 is the leading coefficient? No. So then I'm looking to determine two numbers whose product is and whose sum is. Sum is 1. So let's find two numbers whose product is 2 and whose sum is 1. What do you think? Thank you. They don't exist. Not factorable. No one can find two numbers whose sum is 1 and whose product is 2. They don't exist. Okay, got it? Special order? Okay, 1 minute on this, on your own, please. 1 minute. Between now and Thursday, you can also work on these two. Both are done. We are not going to get to the last two tonight, but I will get to this one tonight. So the last two are applications, and we'll do them possibly Thursday or next week. Say it again. Okay, it's a trinomial. Is it in descending order? Greatest common factor? No. Negative leading coefficient? Special product? One is a leading coefficient? No. Okay, so then I'm down to the very last option. The product is? The sum is? Careful. Negative 26. So do we have two numbers whose product is 25 and whose sum is negative 26? If the product is positive, both signs have to have the same sign, either both positive or both negative, to get a positive product. But since the sum is negative, they both must be negative.
-5. Yeah.
And negative 1. Negative 25 and negative 1. So therefore, you will tell me how to rewrite the trinomial.
5x squared
Yes?
minus 25x minus x plus 5.
Excellent. So from the first two, what will I pull out? Good. What is left in parentheses?
X
Yes? Yes? Good. What should I have from the other two? Otherwise, something is wrong. Good. Now I look. Remember, I need sign and factor. Yes? And the factor is? Thank you. So x minus 5 is pulled out. The order is not important. You're correct. You don't have to erase. You're right. But I like to put the common factor in front, but it doesn't matter. And in parentheses? So you wrote 5x minus 1 times x minus 5, which is the same thing. Any questions? On the handout, I have one more. No, I'm lying. I don't. So let's go now to on page 401. So pages 401, 402. I'm directly on 402. Okay, let's look at 15. 7x squared minus 4x minus 11. Actually, honestly, I cannot teach you anything more about factoring. I don't know anything more. You know exactly what I do about factoring. There's nothing else. And you can say, what about polynomials? Yes, in a minute you'll see. So now you can teach this class. Okay, let's do this one together. And then I'll choose another for you. What is it?
Trying
Good. Is it in descending order? I know you're going to dream.
to.
You're going to dream about this. Is it in descending order? Greatest common factor? Negative leading coefficient? Special product? 1 is a leading coefficient? No. So then we are looking for two numbers whose product is, careful, very good, this is very important, and whose sum is good. So, right. Negative 11 and 7. So then what will you tell me to write? How do I rewrite this polynomial? Because it's difficult in 3 terms. I want it in 4 terms so I can use factoring by.
Grouping.
Thank you. So you will write 7x squared minus 11x
Minus 4.
If I do write 4x, I will not get negative 4. Plus 7x and minus 11. Good. So now from the first two. Careful. If you wrote it the other way, don't erase it. Continue like that. You'll get the same answer. I promise you. Okay. If you want, I can change. If you want, I can change it. I can change the order. It's not going to make any difference. Okay, from the first two.
X times 7x minus 9.
What should I have from the other two?
7x minus 9.
Sign and factor. What do you pull out?
7x.
And what is left? Very good. Okay, let me choose a couple for you, and then I'd like to finish with polynomials. Okay, number 30. So this is 4y squared minus 2y minus 12. Do we need more time? Okay. Now, if you go to the math lab and they teach you something else there, and you like it, and you're comfortable with it, use it. No problem. If you like a different method, please use it. I'm fine. I need this method anyway for polynomials, so that's why I'm showing it. Good. Polynomial? I'm sorry, trinomial? Okay. Descending order? Greatest common factor? 2. What is left in parentheses?
2 minus the square.
minus
6.
Good. Special product? 1 is a leading coefficient? I wish. So then I need to find two numbers whose product is very good and whose sum is -1. Nick, do you feel a little bit better about this or not yet? Okay. So can we find two numbers whose product is -12 and whose sum is -1?
-4 and
Good. So can anyone dictate the next step?
Rewrite.
Good. So then 2y squared.
minus 4y plus 3y minus 6.
Excellent. So then from the first two, what will you pull out?
We already go back with this test.
You'll see in a moment.
2 1.
What should I have coming out from the other two for sure? I know it's there because I found the numbers. Y minus 2. So I'm not fabricating it. So then, yes? Do you all agree with plus 3? So then 2 is out. Now what is the common factor that will come out?
2 minus 1.
And what is left in parentheses?
2y plus 3.
What was the part of the brackets again?
Because I had a factor outside. If I didn't have a factor outside, I would have not put the brackets. You can use nested parentheses, but I think it's better if you use brackets in this case when there is a factor outside. Ready? Ready? Any questions on this? Okay. The strategy of for factoring polynomials. Last one. This is it. Strategy for factoring polynomials. By polynomials, we mean 4 terms or more. I do not mean binomials and I do not mean trinomials. This is the easiest possible strategy. This is the easiest. Number 1, what is it? Number 2, descending order. Number 3, greatest common factor. Number 4, negative leading coefficient. And number 5 is factoring by grouping. There's nothing else. No special products, nothing. Nothing. This is the easiest. You should always hope for 4 terms or more. Or more is questionable. 4 terms. Okay. On page oh, I do have my handout first. I'm sorry, I forgot. Okay, here it is. X to the third plus x squared plus 2x plus 2. I'm asking myself, what is it? And the answer is polynomial. Polynomial. The answer is polynomial. Number 2, is it in descending order? A greatest common factor. Negative leading coefficient. Okay, I'm down to factoring by grouping. So what will you factor out from the very first 2? More. X squared. What is left? Very good. What should I have coming out from the other 2 for sure? Good, now I look, only now I look. I need sign and factor. Greatest common factor comes out, which is? What is left? That's it. This is really the easiest possible. And I don't have to show you factoring by grouping because I already did in trinomials. So x cubed plus 2x squared minus x minus 2. What is it? What is it? Polynomial. Is it in descending order? Yes, degree 3, 2, 1, and 0. Negative leading coefficients? Greatest common factor? No? Okay, then I'm done. What will you factor out from the first two? Careful. Good. What is left in parentheses? What should the other two have? Absolutely. And now I look. I need sign minus 1. Good. So then x plus 2 comes out. And what is left in parentheses? Well, however, x squared minus 1 is a binomial, which is factorable. How do I factor x squared minus 1? X plus 2, x minus 1, x plus 1. Any questions? Okay, here's the third one. That's for you. 2x cubed minus 6x squared plus x and minus 3. So please factor this. Go through the strategy for polynomials, please. So now this is done as well. Okay, all these are finished. What I would do, I would redo all problems we did in class first. Okay, so these two on Thursday. So, what is it? Polynomial. Is it in descending order? Greatest common factor? Negative leading coefficient? Good. So I'm down to factoring by grouping. From the first two, what will you factor out? Careful. 2x squared indeed. The key is the maximum common, greatest common factor, right? The greatest, max. Which is? What should I have from the other two? Now I look. Indeed. So 2x squared times x is 2x cubed. I'll rather check. 2x squared times negative 3 is negative 6x. So then x minus 3 is the common factor. What is left in parentheses? But 2. 2x squared plus 1. Good. So now allow me just to choose a couple of problems and then we'll stop. Let's say 73. on page 381. So 2x to the fourth plus 5x cubed plus 2x squared plus 5x. And then just one more and I'll stop, I promise. So, and 84, which is 15x cubed plus 5x squared minus 6x and minus 2. What is it?
Polynomial.
Descending order? Greatest common factor? Negative leading coefficient? Okay, so factoring by grouping, there is nothing else. No special product, nothing. So from the first two, what would you pull out?
X cubed,
Good. What is left in parentheses?
2x plus 5.
What will you get from the other two? Okay, now let's look.
X.
When I asked greatest common factor, you said no, and I didn't look. It's not your fault, it's my fault. So I have to factor out x. So 2x cubed plus 5x squared plus 2x plus 5. That is mandatory. I have to do that first. And then I have x, and then you're right. I will factor out x squared, and I have 2x plus 5, and I have plus 1 and 2x plus 5. But I have to factor out the greatest common factor first. And everything else was okay. So it's an x outside, a 2x plus 5, and an x squared plus 1. And the last one. And then we'll do everything one more time on Thursday. And applications, because the question is, why am I doing all this? Why is factoring so important? What for? So then you'll see what on Thursday. Why is it important? Okay, so descending order, it's a polynomial. Is it in descending order? Yes. Greatest common factor. Greatest common factor? No. Negative leading coefficient? No. Factoring by grouping. There is nothing else. So from the first two, what will you pull out? 5.
Squared.
Good. What is left in parentheses? So let's try. 5x squared times 3x is this, but 5x squared times 1 is this. So then what is coming out of from the other two? And then in front, sign and factor. Very good. So finally, the greatest common factor is, I would prefer writing it first, but it doesn't matter, you're right. And 5x squared minus 2. This completes all possibilities, all different situations of factoring. There is nothing else.